All right, let's talk about the equation of a line as far as vectors are concerned, yeah? So when we want to find the equation of a line, it's pretty much the same thing that we do when we are talking about equation of a straight line, even on graphs, where we say that equation of a straight line is equals to, we say y is equal to mx plus c, where c is a constant and x and y are my variables and m is a multiple or is the gradient, yeah? So in this case now, suppose that we have OA, which is a position vector, and we have B, which is a directional vector. So OA is a position vector, then B here is a directional vector, right? What we need to find now, we can actually find the equation of a, so we're saying that, suppose this is the line, the point here, we're saying that this is A, this is OA, probably from a certain fixed point, or this is AOA for us, right? We have a fixed point on the line, which is a positional vector that's 2, 1, 2, like this. Then we have maybe the directional vector, probably the vector that is parallel to this. So we're saying that this can actually be B. So B is going to be coming through as our directional vector. So to find OR, any position vector on this line, we can just add the fixed point to a multiple or to a product or to the positional vector which is multiplied by a certain variable. You get the point? We multiply the directional vector with a certain variable and add it to A. We can get any point either here or even here. So that's what we want to find now. That's where we are actually supposed to be finding the equation of a straight line. Yeah. So let me just take my eraser and I can erase this. Oh, come on. It's okay. I can erase this. Let me just erase this part here, and I can replace this with just a B like this. Let me just put a B as the directional vector like this. So our equation of a straight line is going to be coming through like this. R is equal to OA, which is the positional vector, plus lambda of the directional vector. That's all we need to do. So in this case here, we are saying that R is equal to OA. We are already given that's 2, 1, and 2. Adding that to the lambda of the B, which is 3, -1, and 5. Take note that you can always represent this in any way, like even R is equal to 2I plus J plus 2K. All this plus lambda of 3I plus, minus J, then plus 5K. You can still be allowed to have it like this. So this or this are going to be coming through as your equations of the equation of the straight line, innit? I hope that makes sense. This is the simplest version of it. You'll be given the positional vector already and the directional vector already. All you gotta do is substitute them in this equation to get the equation of your straight line, right? That's one way of actually having it. The second part now is when you are given all positional vectors on the line, right? You are being told that A per se is equals to 2, 1, and 3, right? Then you are being told again that maybe OC is equal to 3, 1, and 4, right? In this case, my equation is going to be coming through to be R is equal to, we can choose OA, we can say OA plus the directional vector here can be AC or CA, so it's just going to be AC like this. If you start with the positional vector of A, it's supposed to be A to C. But if you start with the positional vector now of OC, it's supposed to be now the directional vector of C to A. I hope that makes sense. Start with C, you start with C. Start with A, you start with A. That's basically what's up. So let's find AC real quick. AC is the same as C minus A, so which means it's equal to 3, 1, and 4. We are lessing now A, which is 2, 1, and 3. So if we less these guys, going to be getting 1, 0, and 1. This is going to be coming through as my positional vector for AC. So I now have the positional vector. Now I can now form my equation by saying what? R bar is equals to OC. Let's start. We've just obtained OA, right? We just obtained AC, so we can use this. OA, that's 2, 1, 3 as my positional vector. I'm adding that to lambda. Lambda of what? Lambda of AC. Of AC I just obtained, which is 1, 0, 1. This can be rewritten as I said before, that R bar is equals to 2I plus J plus 3K plus lambda of I plus K, because there is no J on that. Yeah, this can be the equation, or we can just choose to use this one, because our OC is just going to be the opposite of this. So my OC is just the same as -1, 0, and -1. That's my OC. Oh, sorry, that's my CA, I meant to say. That's my CA. So at the end of the day, I can just go ahead and actually form an equation using this, where my R bar is now going to be equal to OC. OC is 3, 1, and 4. Plus lambda of what? Of CA, which I just obtained, which is -1, 0, and -1, like this. So these and these are pretty much the same. So you have to make sure that you know that when you have started with A, you're going to be starting with AC here again. That is, if you are given positional vectors, you have to find the directional vector by yourself. Just know that this is how you would solve it. So what's supposed to be stuck in your mind is this or this. You need to know that that's how you find the equation of a line. I'm pretty sure that you knew about how to find AC. It's just subtracting C from A. It's just subtracting A from C. I hope this is clear up to now. So the last thing that I might need to mention on this is the part that, suppose that I am given my OA. This part is very important. Just master it. Suppose that I'm given my OA is X0, Y0, and Z0. Then I'm given again my directional vector B being equal to A, B, and C. And I'm being given again, let's say my my R, any variable positional vector being equal to X, Y, and Z, right? Which means at the end of the day, if I'm going to be writing my equation, which says that R bar should be equal to OA plus lambda of B, lambda of B like this, I can actually just rewrite it as X, Y, Z is the same as X0, Y0, and Z0. All this plus lambda of A, B, and C. And this version now is what is called a vector equation, right? This is a vector equation as we have been doing, yeah? But you can rewrite this again in a parametric form, whereby you say that X is equal to, then you join these two guys all together. X0 plus lambda of A, whereby Y, okay, XYZ, you can just put XYZ here, is equal to, Y part is going to be equated by Y0 plus lambda of B, then Z0 plus, Z is going to be equated to Z plus lambda of C. So at the end of the day, this, what you have here is just the same as this, but this is in the form of a what? Of a Cartesian format. Yeah? Cartesian form. So just know that at the end of the day, you might need to actually rearrange your vector equation to be in the form of a Cartesian plane to solve your equation. The last part that you're not going to be using, sorry, this is the parametric form. Blimey. This is called a parametric form, yeah? It's called the parametric form. The Cartesian form now is when you're going to be equating all these guys now, coming through to say that X, if you just want to find the value of lambda here, it's X minus lambda A, sorry, X minus, if you want to find the value of lambda, X minus X0 divided by A should be the same as Y minus Y0, all divided by B should be the same as, again, Z minus Z0, all divided by C. So this is now, we are now calling the Cartesian format. We might not use this, but this definitely we're going to be making use of. So make sure that you master this in your head, that we can actually represent the equation in parametric form or a Cartesian form. So here's to find the values of some unknowns that we might be demanded to find as we will be doing our work. So just make sure that you know the different ways of presenting the vector equation. So this in your head, this in your head, and this in your head. Again, this has to be stuck in your head always. The second way of actually being asked the same question, but this is the simplest form, whereby this is the raw form of a equation of a line, of vector line. If you are given the position vector and the direction, it's pretty easy. Just do a mere substitution. But if you are given two positional vectors, you might need to find the directional vector, then you do the substitution using either of these. Then know that whenever you now have the equation, you might be asked, or you might need to convert it into parametric form or in a Cartesian format. So he has to find the value of whatever the question might be demanding. Yeah, that's pretty much as far as the equation of a vector is concerned. Make sure that you are able to master this, and if there's any question, please touch base with me.